do. All right, let me open this call. Welcome to our Women and Drones Fireside Chat. It's our weekly drone date. And I'm so glad that we've got gentlemen that join us every week. In fact, I was expecting one other who's probably load shedding and who can't get on. But he said to me today, oh, I thought this was only for women and I didn't want to interfere. I'm like, no, it's open to everybody. So this is our chilled and yet energetic and chatty platform to share information, to learn, to inspire. And I am so thrilled today to be able to welcome our guest speaker, Dean Polley. I've known Dean for a couple of years. He's been in the drone industry for longer than I think the drone regulations have been out in South Africa. So let me quickly, while Michael's on. Okay, cool. So let me introduce Dean. Dean has spent about 26 years of his career in industrial and corporate information tech, of which 10 years he spent in the Middle East. So because I lived in the Middle East as well, oftentimes we have lots of stories to share. Dean got into the drone industry in 2013, initially as a hobby. Dean, and I may ask Dean to share some of this, but he is an avid and quite well-known wildlife photographer, and that's where he really started with his drone photography. And then he saw the enormous potential drones had to offer in various industry segments. And in 2015, he founded his own company called Aerial Vision Africa. That company still exists today, just in a different name, goes by SAS Holdings. And that's basically a company that's positioned as a provider of turnkey drone solutions.
Uh-oh, did Kim freeze on us?
Yeah, I wonder if...
Okay,
so
I think
Dean
so.
and our company do quite a WASA, our commercial unmanned aircraft, much involved.
Sorry, Kim, we lost you there for a moment.
Oh my goodness. Okay, so I was just going to say, Dean is still involved in the industry. He is on the board of directors in CASA, which is the umbrella body, the Commercial Aviation Association. So Dean, I hope I've done you justice. I'm going to hand over to you and we look forward to hearing from you.
Okay, Kim, thanks very much. And thank you for inviting me to your Fireside Chat. I think Fireside would be very welcome at the moment with this weather we're going through. So I'd love to be sitting around a real fire. All I have now is a fire coming out of a gas heater. Let me just put my presentation on. And if I'm able to share my screen, what are we looking at? There we go. Just tell me if you can see the screen. It should be our company logo called SAS.
It's loading, Dean.
Okay, there we go.
There you go.
We're all on board? Okay, thanks. So Kim asked me to just touch on the first world area that I live in. So this is actually where I live and work from. And I'm doing this call from my home right now, based out in a small private game reserve, about 30 kilometers, 16 miles north of Pretoria, the capital city. So even though it may look like deep and darkest Africa, in literally 20 minutes, I'm in a bustling city. But I love living out here. And by the way, there's no lions and elephants here. We only have what's called non-lethal animals, antelope, small buck, and the likes of. So Kim's asked me to touch on or speak a little bit about photogrammetry today, and touching on Pix4D, and in particular, using this technology to map underground mining. So I don't know if you, just as by the by, in this last 2 weeks, Pix4D, those of you that know Pix4D, is actually rebranded as well. And that is their new logo as of June 2021 going forward. So if you haven't been notified of that, if you go to the website now, you'll see the new logo and branding is actually active. So
I love it. It looks great. What do you think of it, Dean? It's good, right?
Yeah, it's got a very modern look. And I don't know what more to say about it, but they've, the old one, I actually like the old one, but the new one works for me as well. So just in very simplistic terms, what is photogrammetry? So photogrammetry is the science of making measurements from photographs. So the input to photogrammetry is typically photographs, and the output is typically a map, or otherwise known as an orthophoto or an orthomosaic, a drawing, a measurement, or a 3D model of some real-world object or scene. So many of the maps we use today are created with photogrammetry and photographs taken from aircraft, and it's become quite a common practice. I know a lot in South Africa and elsewhere in the world where drones are being used very effectively now to do aerial survey, create photographs, and being processed in photogrammetry software like Pix4D. So that's an example of a orthomosaic or a map in Pix4D. This was just a test that we did at a radio-controlled flying club. And just bear with me. This is a very short video, and I hope it plays. It'll stream a bit, or buffer. And that's the same view, but a 3D, that's a 3D point cloud, a very dense 3D point cloud of the same model. And that's what Pix4D will allow you to do. So I'm not going to let it play through because of bandwidth issues. Let's see if it'll move forward. So what is vitally important for aerial survey, especially with drones, is the ability to be able to write geopositioning data into an image. So if you're familiar with the term EXIF, so if you, just a normal digital camera, if you take a photograph and you take that image into an application like Photoshop and you go and look at the file properties, you will see that there's a lot of so-called EXIF data or metadata, if you want to call it that, in a photograph. So it'll give you the name, the camera model, the lens that was used, the focal length, exposure, parameters such as ISO, shutter speed, aperture, etc., etc. With drones, it writes all that information into the JPEG file, but it also takes its current GPS position, and for every image that it captures, it'll write that exact position at that time into the image. And why that's important is, and this is just an example of one of those images that made up that orthophoto that I showed you, and you'll see that this was flown with a DJI. It was a DJI Phantom 4. If you look up that model number, it'll refer to a DJI Phantom 4. That was the focal length. You'll see what the exposure was. The image size is a 4K image. Orientation, typically it's a 4:3 aspect ratio, and it was a 72 pixel per inch image. Because the DJI Phantom does have an onboard GPS, for this particular image, it wrote that position of where the image was taken. So that is the GPS coordinate plus the altitude, which is your, in this case, meters, but it could be feet above mean sea level. So every image that's captured has this data written into it. And then Pix4D, when you take all the images that's been flown over an area of interest, it's able to position it on a map as per this image here. So every one of those red dots was a photograph taken in a grid format. And obviously there's a relative typical overlap of images would be sort of 85% front overlap and 75% side overlap. So that is that area that we flew. That's the 3D point cloud. And those are the camera positions in Pix4D. So you can see that every green dot is where the drone was, and the corresponding photograph is the angle of view. Okay, my internet connection says it's unstable. Can you still hear me?
Yes, we can still hear you.
You can
Yes.
still hear you, okay.
Yes.
So there, that is showing you the position of the cameras, or the position of the camera and the resulting images that made up creating this orthophoto map and the 3D point cloud. So now, this is a relatively new technology, and we're taking drones underground. So this is the Elios 2 inspection drone, and you're welcome to go and have a look at, it's from a company in Switzerland called Flyability, and this is the second generation of this drone. So now, of course, you're underground and you do not have a direct view of satellites, so you do not have a GPS coordinate. So the challenges are, how can you do photogrammetry using a drone underground if you don't have GPS reference or a georeference location? So this, although it really looks simple, this is an incredibly sophisticated piece of equipment. So instead of a GPS, it has a barometer, which gives you your altitude. And typically, it'll be your altitude from where you take off. So before you start your flight mission, you will zero your barometer, or like a tear, and it'll then calculate in real time as it's flying its altitude by means of the barometer. It then also has a digital compass, so you also zero your position or your angle of view, and then as you're flying, the digital compass will pick up in real time the direction or the heading of the drone. And then the drone has a 360 position sensors. There's 7 in total, and these sensors are working in real time and detecting and measuring its distance. So if I go back to this image here, as the drone is flying down, it'll be continuously measuring its distance from the sidewall, and that distance is quite accurate. It'll tell you in centimeters how far it is from an object. So in this environment, the sensors will be detecting the floor, it'll be detecting the roof of this tunnel, and it'll be detecting the walls. And as it's moving along, together with the barometer and the compass heading, it's able to determine, like georeferencing information, but more in context of the environment that it's flying. So I just spent 3 days delivering this system to a mine in South Africa. So you're all familiar with Anglo American. They're an international, well-known mining group in the world. And this is the first mine in South Africa, if not on the African continent that I'm aware of, that have actually purchased the system. So it's this Elios 2 drone with Pix4D mapper in order to map their underground operations. So as with normal aerial survey, you can see now in this Pix4D model that it's able to determine the positioning of the cameras in the flight path that we flew. So we flew with the camera pointing towards the wall. So this is a top-down view, as if it was an aerial view, and we fly sideways. And you'll see that the images are tilting. So in order to get overlap and coverage, we're actually tilting the camera up to the front and to down to get overlap of the environment that we want to map. We fly sort of a U, like in a U shape, fly down there, get to the end, turn around, and we fly back here with the camera facing the wall all the way to the end. So what that does, it gives you a pretty accurate point cloud. So this is now as if you were standing in the tunnel, looking down the tunnel, and you will see that the whole model is twisted at about a 45-degree angle. So because there's no georeferencing and no reference to a GPS coordinate system, the drone actually doesn't really know what's up, what's down. But what it does do, it takes those images with reference to the info that it's got, and it builds an initial point cloud. So if you had to go and measure that, so I know that that distance over there is about 2.5 meters. In this context, you'll see that it actually gives a measurement of 40 meters, which is impossible because the total width of this tunnel is only 3 meters. So what Pix4D allows you to do is what's called a scale and an orientation constraint. So it allows you to create manual type points. So we have 3 manual type points here. Between these two, we are able to do what's called a scale constraint. So we know that the distance from there to there is exactly 2.65 meters because it was measured with a measuring tape. So you mark your scale constraint, and you key in the exact value that represents the distance between those 2 manual type points. Then your z-axis, which is your vertical axis, you create another type point, and you create what's called an orientation constraint. So you mark from the bottom to the top, and you are telling Pix4D that that is my z-axis. You then what they call re-optimize the model, and what you get is it'll actually take the entire point cloud and it'll scale it according to the measurement that you gave it, and it'll turn it to the orientation that you want. And I did have a video, but I don't think it's going to play. But effectively what this allows now is, as conveniently that you're able to use drones to do aerial mapping of fields above ground, you're now able, with different technology and with Pix4D pulling that all together, to be able to accurately map areas underground, and also in particular in areas that are inaccessible to humans. So there are some areas where miners need vital information, but they can't get to it because of size. I mean, you're looking at a roof height of 0.5 meter. You literally have to crawl or leopard crawl through there. It's a very, very harsh environment. And now with this technology, it opens up a whole new door of opportunities. And I must say, this is really cutting edge and very exciting technology. So now when we take that corrected image, or that corrected point cloud, and we do a point cloud measurement, you will see that we are actually 1 millimeter out. So the measurement, and probably is because I clicked on the wrong point, but there is the correct measurement, 2.64, 2.65 meters. So the next step is, in mining, as they are excavating, the mine surveyors will actually survey a point in the ceiling, and then they hang what's called a survey rod, and that is just like a polystyrene ball. So that is a special survey rod that's got a particular length, and you can now go and click on a number of these survey points, and you can manually go and enter the GCP or the ground control point data. So now you can put real-time georeferencing or GPS coordinates in an underground environment. So just like you would use ground control points to have a geospatially correct aerial survey, you can now add that accuracy underground and build a very accurate geospatially correct underground mine map. So that concludes my very short talk. And so Kim asked me to add something in with regard to my photography. These little babies actually are resident in the ceiling of my patio. And I think I've got thousands of photographs with them. And this is one of the really super shots I got one afternoon. And It earned me an award with Africa Geographic, which is one of the leading wildlife online magazines in South Africa. So with that, that's my story, and I'd be more than happy to field any questions if you may have.
Dean, thank you so much. Well, I don't know what to talk about first, this little bush baby or your underground mapping. So yeah, let's go to the Elios and the mapping. It is so fascinating just to think that inaccessible mining, area is now, kind of so easily accessible with technology. Obviously, it's not cheap. But what did they do before, Dean? So if you say it's a 0.5 meter tunnel, potentially dangerous, but really just physically inaccessible, how did they measure these things before?
So they use a combination of physical measurement. They use total stations. So your professional survey total stations. So, I mean, this is quite cumbersome and heavy equipment that they've got to carry down into a mine. And there's 2 ways of going down into these mines. One is to go down in a cage, which is not a very pleasant experience. And the other one, which is really quite cool, is it's about a 30% decline. And you actually go down sitting on a little, what do you call it? A little cable. It's like a little cable car. So you've got this cable car running down down this incline, and you hop onto it. It's got a little seat and 2 sort of rests for your feet and a bar. And then you hold on to this thing, and it takes you all the way down the mine. So to carry equipment down is first of all difficult because of the size, the weight, and imagine a survey tripod. I mean, that alone is quite cumbersome. So in order to take this equipment down, you have to split it up between the teams. So you're looking at 4 to 5 people carrying all this equipment down to the level that you want to measure. So total stations is the most common way of measuring and georeferencing. And then LiDAR is being used as well. But LiDAR again is also, it's large pieces of equipment and heavy pieces of equipment. So that is all fine in an area where it's accessible to walk upright or straight. And then to set up this equipment and calibrate it also is very time consuming. So this model here took 10 minutes to fly. So we flew down, we flew back, and we were done in 10 minutes. Whereas the same measurement and to get the same result would literally take an hour or 2. So that is let me go back there. So those are the challenges that they've been facing. And then when it comes to areas like stopes or really difficult places to get to, they just don't measure that. So they are working on sort of physical, visual records, taking photographs, etc.
That's just so fascinating. I just love it. I mean, the other comment I have, and I think it goes without saying, but oftentimes people think, I want to get into the drone industry, just get my remote pilot's license, and give me a drone, and I can go and find a solution. I can go and find a problem to solve. I mean, clearly in this instance, it's highly technical work, even though a drone can make this, work a lot faster and a lot simpler from an application perspective, but you still really need to know what you're doing. That was just a comment around, you need to be a surveyor, or you need to know your software to set it all up, like you were explaining, right?
Mm-hmm. So yeah, it's a very good point, Kim. So first of all, as you say, the end user is typically a mine surveyor. They're not a drone pilot. So in delivering the system, we had to put them through a comprehensive, it was a full 5-day training. So the first 2 days was literally just on the drone. So it was And we had to cover things like you do with normal above ground drones. So Lipo battery management, charging of batteries, checking things like your voltage levels while you're flying. Although the software, pretty much like a DJI Phantom, will give you warnings telling you, start alarming when you've reached your critical battery level. It actually flies exactly like a DJI drone. So your controls are the C2 configuration. And then, it flies as stable as something like a DJI Phantom. So because these guys had never flown drones before, they had to learn to fly a drone. So they had to learn a lot of the theory and the practical that you would with flying normal drones, except that, there's just other concepts where, we did a training inside an office, which any DFE or CAA personnel would probably be cringing if they heard me say that. We were flying under desks and sort of along the walls and under chairs. We created like obstacles for them to fly through. So what's different about this from a safety point of view, it is very safe, in fact. So you can literally fly against a person, and because of that ball structure, so this that is actually a round ball made up of thin carbon fiber strands, and the drone is suspended inside there. So you can literally fly and bump into the wall, bump into the ceiling, sort of bounce off the floor, and I actually flown it into myself at one stage. And because of the drone is in the cage, the propellers can't actually reach you. So there is a workflow involved, and there is a structured program. So the training covered the practical flying, and then there's sort of specialized flying for photogrammetry. And what's also quite nice about this drone is it's got a photogrammetry mode. So when you're flying, it actually, sort of slows down your controls so they're not so responsive, and it flies quite slowly. And then when you tilt your camera, instead of a smooth pan, it changes angle in sort of fast steps. So it actually makes it quite easy. And then there's a process involved in extracting the data and processing it and preparing it for Pix4D. And that's about a one-day training. And then the actual taking the data and then processing in Pix4D to get the end results was another 2-day process. So it was a 5-day process all in all. But even though it's like, if you take a rookie and you put them through the initial RPL training and they have an RPL, that doesn't necessarily say they're highly competent in flying that drone that they got the RPL on. So there's still a lot of work up front. They got to put in flying time. They got to practice in processing. The more time you spend with something, the more sort of efficient and competent you become.
Oh, that makes complete sense. Thanks, Dean. Ella, you have had your hand up for a while. Do you have a question?
Sorry, yes, the dogs just started barking. I wanted to say, Dean, I think what you are doing is amazing. Coming from a mining background, I know of many incidents after blasting. The surveyors have to go in, and unfortunately, many has lost their lives because of the uncertainty of the rocks and everything. So I think from a safety perspective, this is really amazing, and I think it's really cool.
Ella, thanks. Thanks for that. And that's the other aspect of this. So the drone, this particular drone is not just there to be used for photogrammetry.
Did Dean freeze up? Or did I freeze up?
I think Dean's frozen. I'm sure it'll come through. Unless
it was an eclipse last night, so
yeah.
Things are crazy.
Unless they've gone into load shedding, in which case he's going to have to switch over onto 4G or something. Let's see. Load shedding. Let me just see. Can you switch over? We might have lost him.
Yeah, I think we lost him. Uh-oh. Is everyone else?
I've got a question while we're waiting for him to come back.
Yes, go ahead, Craig.
It looks like Kim's also gone.
Yes, I think, well, she's also dealing with the load sharing, but go ahead. Let's see if someone can answer your question.
So I wonder if it requires now a new definition to beyond visual line of sight. Because now this drone is like looking around corners in a mine and it's not in line of sight by definition.
That's interesting. That's a great question. Desi, I saw that you on. You want to take a stab at that?
You know, my question also is before that one, being that it is not outdoors, the flights are inside, what are the governing bodies for it? I know here, the FAA controls the National Airspace System, but once we get inside, it's a whole different ballgame. And so they may not be following within that same guideline. So I'm curious to know if the same rules would apply, being that they're actually flying indoors in a sense. So the beyond visual line of sight may not pertain to it.
And that's a great point. However, then it just becomes, what are your safety protocols? Oh,
right.
Kim's trying to come back in. Kim, you're breaking up still. Anyway, I think that's a great point, Desi, and it still would be important to understand what are the safety protocols, because it is still beyond visual line of sight. So great question, Craig.
It's low now. Okay, can you guys hear me? I've just switched over onto our Wi-Fi. Can you hear me now?
Yes, we can hear you.
Oh, perfect. Okay, so I have Dean on the phone because he has now been plunged into darkness and he has no Wi-Fi. So he's heard, I've got him on speaker, so he's heard your questions and your comments. So Dean, do you want to respond to that? I don't know if they'll be able to hear, but essentially Craig also asked whether this essentially also, kind of would bring beyond visual line of sight into play, because potentially you are kind of flying away from you down tunnels where you no longer have line of sight of the drone. And then, of course, Desi asked earlier on the chat, being inside, do the pilots still require an RPL?
Okay, so thanks for those questions. Before I answer them, can you just confirm that they can hear me through your phone?
Yeah, so I was just going to say, can you hear him speak?
Yes.
You see, the technology's great, so let's continue.
Okay, so first of all, the question about beyond visual line of sight is a very good question. So flyability has something called a range extender. So it's a 20-meter length of cable with so you remove the standard antenna blades off the remote control, and then you screw in this cable, and then it's got a flat antenna that's powered by battery to give it power, and you actually can push this then into a tunnel, and then which will allow you then to fly the drone around the corner and then go up to about 500 meters. So yes, it does cater for things like that kind of beyond visual line of sight. So does that answer the question?
Craig, did that answer your question?
Yes, it did. Thank you.
Perfect. And then what about the RPL? For if you're not flying in airspace, right? So do the pilots still require an RPL?
So there's not a definitive answer for that, and it's a pretty grey area. And at the moment, in South Africa, that is, there is a split in opinion about that. Around the world, it's not an issue. And I've tried to look at it from our own Part 101, and there's very little about Part 101 that you can actually conform to. And I would argue that because you are flying inside a building or underground, you're actually outside of civilian airspace, so it doesn't fall under the CAA regulations. Having said that,
The argument is that you now, in strict terms, you're flying a drone for commercial purposes. And CIA, but if we go back to the origins of the regulations in South Africa, and Kim, you may have heard CIA many times justify the complexity of our own regulations, all based on aviation safety. So, first of all, underground, you are not in civil aviation space, so there's no way that you can interfere with any kind of aviation safety. The drone can't do a flyaway. There's not really much far it can fly. And secondly, flyaways are usually related to GPS. So a flyaway will typically fly towards a certain GPS location. So because it's not navigating via GPS, it can't fly away. If it did, or if it could, as I said, you're in an underground tunnel, it's going to fly into the wall and it's not going to go anywhere. You're not flying anywhere near, well, you're not flying, strictly speaking, you're not flying near people. And the people that you are flying near are the authorized people that are there for you to operate the drone. And in most cases, you're actually operating in an area that is inaccessible to humans. So it's the opposite of providing a threat to human safety. It's actually enhancing human safety. And then because of its design, the likelihood of it injuring you should you fly into a person by mistake is very low. And if you fly into infrastructure, to damage that infrastructure is very limited. You're conforming to, and in fact, when you're flying in a mine, we had to go through a process where we had to meet mine safety requirements. And if you've ever been into a mine and know what their safety requirements are, it's really, really hectic. So we have a standard documented method statement that we have to submit, and we have to do quite a comprehensive risk assessment before we even start the drone up and fly in that environment. So again, to come down to regulation, there isn't a hard and fast answer. There's a split in opinion, and some will argue for, some will argue against, but right now it's not defined.
Thanks, Dean. And I think I would just comment to that specifically with that type of drone. The risk really has been eliminated because there are no exposed props. We were at a conference recently where there was a company that presented, and they actually use M300s underground to do similar work. Ella was actually at that conference. They used 210s and M300s. And of course, there the same questions came up with regards to the regulations, but there the conversation turned to safety from the perspective of exposed props, because you're still manually flying that drone and you could still potentially fly that into a human being, specifically because you're flying probably at head height. So our advice and discussion turned into a conversation that said, even though you most likely wouldn't have to conform to Part 101 in the South African context, that we would still advise putting the operators through the RPL, or at least some form of safety training, but most likely the RPL, because those drones can fly outside anyway, and the mine would most likely, or the surveyors would most likely use those drones underground as well as above ground, in which case an RPL is required.
So just on that RPL, so and as you know, we've had a discussion with Daniel from Unicorn Brokers.
Yes.
We are looking at a sort of competence, an approved competence assessment for the flying of these drones for insurance purposes. So that is an insurance company requirement.
Yeah.
And I think it is a good idea to have the guys going through that training. Secondly, on flying this drone outside, you actually cannot fly this drone in open air further than 5 meters from an object. So what happens when it gets into open space and it cannot find an object around it, it just basically loses itself and you actually cannot fly it. So again, from a risk and safety point of view, you can't take this and use it as a dual purpose and go and fly it outside the front. It just won't operate. On the drones that you mentioned, I think the company is called Emisent. They have put a LiDAR system on the M200 and M300. And they are, I mean, I come up on this topic quite often when I'm speaking with the guys in the drone, in the mines. And some of the mines have actually tried this and it's not working. So it's great, it'll fly in the environment and it'll avoid objects. But the feedback is that, especially the M300, the downdraft of the rotors is so strong that it's just a major dust cloud. Secondly, it's too large to fly into some of the areas that we have flown into with the Elios 2. And thirdly, it doesn't have the simulated georeferencing information that it writes into the images in order to position them for Pix4D mapping. I don't know if they have a different technology for that. So although it meets the requirements of being able to fly in confined spaces and not bump into anything, it has some other inherent shortfalls and risks involved as well. So as you mentioned, there's a high risk if something goes wrong with that drone and it flies into a person. It's going to do some serious bodily harm.
Absolutely. Dean, what's the price comparison between the Elios 2 and, for example, the M300 with the standard, well, it wouldn't be a standard payload, right? But to do the same work, what would the price comparison be? Can they compare?
Unfortunately not. So hold on to your hats and sit down. The total package goes for around $55,000, which is about 800,000 Rand.
Wow. Okay. Gosh. All right. Yep. I didn't think it was going to be that much, but it makes sense.
If I can say something.
Go ahead, Ella.
I know that when you work at a mine, that they have basically no limit of money towards safety. So as long as your motivation is good enough to be very safe, they will pay. So I don't think for mines that would be such a big, it might take longer for you to get approved, but when it comes to safety, the mines are not scared to pay. So that's okay.
I would have thought that too. Dean, we lost you there momentarily, but Ella was saying that.
We're back again.
Yeah, we're back. Ella just was saying that the mine budgets are quite large when it comes to safety. So it might take longer to get approved, but they might actually, opt for the more expensive option from a safety perspective.
Yeah. So I mean, the important thing is, and it really came out with this last couple of days that I spent on the mine. It's not just about the drone, and it's really where my company comes from is a turnkey solution. So the drone is actually only one component, probably the biggest and most expensive component of the complete turnkey solution. That is the data capture. Once you've captured the data, you have to do something with it. That's where the next stage of the turnkey solution comes in. It's the processing of the data, and it's the creation of the value, which is the information in the form of a report, a 3D model, and the ability to be able to do linear and volumetric measurements in the environment that they have scanned.
100%, absolutely. It's all very well selling an organization a drone, but it's that solution they're looking for. Craig, you had your hand up. Do you have a question for Dean?
Yes, a question and a comment also. Dean, I think what you're doing is incredible, and I think it's hugely beneficial not only to mining but to other other companies that have a requirement to map whatever they're doing indoors. I spent 15 years at Anglo American, and I can relate 100% not only to their safety budget, but to the safety requirements. And even though Part 101 might be ambiguous, whether you need a license or not to fly underground, certainly if you meet the Anglo American requirements in terms of safety, you will certainly be, I believe, quite safe to be flying in their property and in their mines. So I just wanted to say, yeah, pretty much that if you've got to deal with Anglo, you're safe.
Brilliant.
Hi,
So
Kim.
Thank you for the compliment as well.
Yeah, that Craig just reiterated what you were saying and to our point on safety. So that's fabulous. Queen, you had a question.
Yes, I had a client who asked me that he needed a warehouse solution because they've got big warehouses, you know. And he asked me what type of drone that they can use. I recommended Elios too because I've heard about it, people talking about it, but I wasn't sure. I was just trying my luck because I couldn't say no, there isn't any solution. And the reason why I recommended Elios too, because I thought it's GPS denied. But I just want Dave to confirm if my intelligent guess was making sense. That you can use Elios 2 for warehouse solutions.
Did you hear that, Dean?
Yeah, so, I mean, again, if you go to the Flyability website and go and have a look at their case studies, I mean, mining, underground mapping is just one of their functionalities. So, I mean, this drone gets used, they put it inside boilers to inspect the inside of boilers, inside furnaces. I mean, they use the Elios 2 to go and do an inspection of the nuclear reactor at Chernobyl. So things like inside silos, chimney stacks, there's a broad range of applications that you can use this for. So inside a building like a warehouse is quite possible as well.
Okay.
There you go. Well done, Queen. Now they just need to buy it, right? And you know who to buy it from. You can buy it from Dean.
Yeah, I know. To get all the advices and all the training as well for the engineers in the mines. Thank you.
And Queen, you have my number, right?
Yeah, I have it, dear. Thanks for a beautiful presentation. Very insightful.
Queen and Dean are both co-authors in Louise Jupp's DP2. So we had a little book launch party recently, all COVID-19 protocols observed, of course, but so we had a nice afternoon together.
The photos are not displaying it.
Let me quickly, if there are any other questions, just put up your hand. But Dean, I just wanted to read some of the comments. Great information from Rudo. This is very interesting. So Dean, you weren't on last week's Fireside Chat, but Desi Eckstein's husband is a gold digger, aka prospector, and so Desi took us on a presentation, but it felt like a tour of kind of historical mine shaft buildings, etc., in these old mining towns. And so basically her comment was, looking forward to my next trip to the gold claim to do inside mapping. So that was Desi's comment, and okay, great presentation. And of course,
sorry, Kim, just to let you guys know, and I hope to be able to share the information in a week or two, but we are looking at, so everyone's familiar with the world famous Cullinan diamond. The Cullinan diamond was discovered about half an hour drive from where I live at the famous Premier mine,
yes,
or the mine as it's sometimes known, which is owned now by Petra Diamonds. And they have a vent shaft that runs 500 meters from the surface down to the bottom of the mine. And it's a diameter of 5 meters. And they have been looking for a solution now for ages to be able to inspect every centimeter or inch of this vent shaft, and also to be able to determine if through underground rock pressures, if this vent shaft hasn't experienced any distortion. And I'm actually being contracted now to go and inspect and map this shaft, which is something that's never been done before. And we've sort of done a risk assessment. And also one of the problems we face is the drone, the Elios 2 only has a 5-minute flying time. 10-minute flying time. So, and we can only access the shaft from the surface. So the challenge that we face is I will not be able to fly the drone to the bottom and back up again with the battery life that I have. So what we're looking at is we're going to suspend the drone on a very thin steel cable with a pulley that will be located in the middle of, or the center of the shaft. And we're actually going to lower the drone to the bottom and then idle the motors and then slowly pull it up instead of flying it up. And in that way, we'll be able to extend the flying time, in inverted commas, if you want to call it that, to 20 to 25 minutes. And we don't have the risk of losing the drone and dropping down this half-a-kilometer vent pipe. So that's going to be a very interesting and exciting project. And when I do get that 3D model, I have to do the entire 500-meter model. It's going to be, I'll definitely share it with everybody.
That'll be amazing. And what a nice solution. That's so innovative. Queen says, wow, congratulations. Very, very innovative indeed. Awesome, says Desi. Can't wait to see once you can share that data. This is fabulous, Dean. Thank you so much for sharing what you're doing. Dean gets involved in some very cool projects. We've done some work with Dean, and he really knows his stuff, and he's been around for a long time. And a lot of overseas clients call him to solution crazy stuff. And then he pulls, you know, operators, equipment, you know, software licenses, etc., and creates that solution. So he's definitely a man to have around. And Queen, you know, for you, for example, when you're solutioning for your clients, Dean should be on your speed dial.
Yeah.
So Dean, we have a few moments left, and I thought just to indulge our American and our Canadian colleagues, please won't you share your little story about Kwande, please?
Okay. So just to put it into perspective, where I live, if you go to the map of South Africa, Pretoria is our capital. It's in the northern part of the country. And north of Pretoria is quite open. There's a lot of game farms, game reserves. We have a rather large one called Dino King. It's a big 5 reserve. So big 5 means it's got lion, elephant, rhino, buffalo, and leopard. And as the crow flies, the small game reserve that I stay on is about 16 kilometers away. So this morning, just before I left home, the residents on our reserve, we're on a WhatsApp group, and we're forever updating and sharing information. So the message came in and said, we've been informed that a male lion has escaped from Dino King, has been seen in the region of the surrounding areas. The rangers are busy tracking him, and they'll hopefully be able to dart him and take him back. In the meantime, some of the roads leading to our reserve may be closed. So please, if you are driving out, be cautious. And I thought, okay, well, that's interesting. So I drove out this morning to a meeting, and I was literally driving, looking on the side of the road to see if I might see this lion. And by just after 10:30, we got a message in and saying, good news, the lion was located. darted the safety being returned to Dinner King. And the area that they found him was about 5 or 6 kilometers from where we stayed. So, yeah, I just sort of thought, well, I'll think twice again if I go riding on a mountain bike outside the reserve.
So to anyone that I always say, no, we don't have free roaming big wildlife in South Africa. We sometimes do. Thank you so much for sharing, Dean. Are there any closing comments? Sharon Rosmark, did you want to say a few words before we sign off?
No, I just want to thank Dean. This was absolutely awesome. He could have gone on and on as far as I'm concerned.
Yep.
I love that picture of where he stays on the, I think it's a game reserve, he said. I'm like, oh, we have to visit there. We have to come and see it in person. And Desi's nodding her head. But thank you so much, Dean. This was absolutely incredible. It exceeded my expectations. And I just can't wait to come and visit all of you. This is just so much fun.
I agree.
Thank you, Sharon.
And I think everyone agrees. So Dean, thank you once again, and please come back and update us on your projects. You can see most of us are now in complete darkness with a few little emergency lights on. So thank you for your patience. I think Samantha Scully said earlier on, the show must go on. So, you know, through some communication, we've managed to finish the presentation. Thank you to everyone who dialed in. We absolutely love you sharing questions, comments on our Fireside chats. Please join Women and Drones as a member. The platform is very resourceful. We share a lot of information there that are for members only, but go onto the website anyway. These chats are recorded, and so once they're edited, they go up. And of course, the Fireside Chat Africa recordings are just going to be hilarious because we power cuts and all sorts, but you know what, it's authentic. So there you go. Thank you so much to everyone. Be safe, and we'll see you again next week. Take care.
Okay, also from my side, Kim, once again, thank you for the invite. To all the participants, thank you for your positive comments, and I'm glad to hear that you did enjoy it. And for whatever your endeavors are, good luck with everything. Stay safe, and until next time.
Thanks, Dean. Thank you so much.
Okay.
Cheers, everyone.
Cheers.
Bye.
Bye. Thanks, you guys. Thank you so much for your participation. And yeah, have a good Friday.